watching how military bullets are made at an arsenal.
Finally made me understand why war burns through money. It really is a rich man's game.
Just the bullet tip alone needs premium materials,
Plus a special casing wrap
to make sure that when the bullet is fired, the tip expands and presses outward,
increasing barrel tightness.
Today,
Let's dive into the crazy money burning behind war.
this is real footage from the Colt Group's arsenal.
The alloy brass plates you see here are the main material used to punch out shell casings. Compared to China and the US,
Western countries have richer copper resources,
so when it comes to material choices, brass is usually the top pick.
the high temperatures generated cause the casing to expand slightly, snugly fitting against the chamber. That's thanks to brass's excellent flexibility and smoothness.
Now we've got our initial shell form,
Each one about 1 millimeter thick.
shaped like a shallow bowl,
Next, they're heat treated at 7075 C.
to relieve internal stress from the pressing process.
The high heat also causes zinc oxide to form on the brass,
Giving it a whitish color. Then comes a reduction process to restore its original color.
but thumb-sized brass pieces aren't usable just yet.
They're sent to the brass bottle press.
Based on set dimensions, the brass is squeezed inward as much as possible. Both the thickness and diameter are now brought to very precise standards.
But at this point, the brass is still super soft. You could crush it just by pressing it lightly.
So,
Another design feature plays a key role here.
this is the neck area.
The neck is used to secure the bullet tip.
Its narrow front, wide back shape also makes the bullet way tougher. If you look closely,
You'll notice both ends of the casing have clearly changed.
especially the base of the casing, there's a custom ring-shaped mark stamped into it. That little groove in the center,
That's where the primer goes. It's what ignites the gunpowder inside. Now they press the extraction groove. After the bullet is fired,
the casing stays behind, inside the gun chamber,
that's why the casing is cleverly designed with a ring groove.
and the gun chamber has an extractor claw. So after the round is fired,
The groove allows the casing to be ejected smoothly. Take the old Type 728 rifle, for example.
you had to manually pull and yank it out. Now it's way more convenient. Next up is a laser inspection to make sure the mouth of the case is cleanly formed.
Then the neck down section gets annealed again.
Since the brass casing is thin, this time the temperature isn't set to high. If you look closely,
You might even spot slight color differences from the heating process. But ammo buyers aren't paying for ugly shells.
so the casings go into a machine.
For another round of thorough cleaning, plus a mandatory polishing process.
This is actually the only part we're allowed to show in detail.
Basically, it's secondary processing. Like on battlefields or training ranges, spent casings that were ejected,
Can be cleaned, repaired, refitted with new primers,
powder and bullets.
and boom, you've got a brand new round. The cleaning process is almost identical to what we saw earlier.
What we're seeing now are the approved, high-quality casings. Any with dents or burrs,
The rejects get lumped into one of 4 wooden boxes below. But even this level of sorting isn't enough,
to avoid jamming or explosions.
and reduce soldier casualties. The line is equipped with optical inspection systems.
Cameras inside the system can detect even tiny scratches or minuscule defects invisible to the naked eye.
Nothing gets past them. Next comes primer loading. If you're curious, you don't want to miss this. Primers are usually made with impact-sensitive chemicals.
Like potassium nitrate or mercury fulminate, there's also oxidizers and flammable binders added to the mix. First, the primers slide down from the box in front of us.
The primers are aligned with the casings.
Then they're pneumatically moved down into place.
What you're seeing now is the primer being installed.
After that, a sealing compound is applied to the base because these sensitive chemicals will ignite on impact from the firing pin.
Instantly.
The sealant acts as a protective barrier.
Next comes the bullet itself. The wire-like material you see is actually lead.
There's also zinc and sometimes a steel core. So not all full metal jacket bullets are made entirely of copper. Take steel for instance,
It's incredibly hard.
but it wears down the barrel fast.
That's why the bullet is often jacketed with a layer of copper. When fired, the copper jacket expands and presses outwards
to maintain a gas-tight seal in the barrel. Grooves from the rifling also get pressed onto the bullet's surface. If you try inserting a bullet into the barrel muzzle first, with the copper end going in,
chances are it won't even fit.
And just like that, a lead core copper jacketed bullet is done. At a glance, it already looks like a complete mini bullet.
Now it's time to load gunpowder into the casing. A vibrator is mounted above. Each vibration causes the powder to fall.
This controls how much powder goes into each casing. Then a robotic arm inserts the bullet into the casing. It might look risky on screen, but as long as the firing pin isn't triggered, there's no real danger.
So basically, most bullets in the world are made using this compression method. Since their invention, bullets have mostly used copper casings.
Copper is ideal because it's smooth, doesn't rust, stores well, and is super malleable.
The downside, it's expensive.
And in China, copper is relatively scarce
From a strategic standpoint,
it's not ideal for mass production.
So domestically, copper-coated steel is often used.
Or check steel as an alternative material. It works just fine in real-world usage.
But performance-wise, it still falls short of full copper.
Meanwhile, countries in the West have money to burn and abundant copper reserves,
so they can afford it.
That's why they mostly use brass casings. Take this current batch, for example,
Destined for the Russia-Ukraine battlefield.
they're all loaded with brass casings. Of course, that includes pistol rounds too. The manufacturing process for pistol and rifle bullets is nearly identical. The biggest difference lies in the propellant used
and the size of the casing. Next, the primer is injected, followed by a layer of sealing lacquer.
It's then baked to ensure the sealant holds firmly in place.
A single box of ammo weighs around 50 grams, and instead of being sealed in metal tins,
They're usually packed in disposable paper boxes for easy unpacking.
in other words, once production is done, the ammo gets shipped straight to the front lines.
Some bullets go from factory to battlefield in under 5 days. Besides pistol and rifle rounds, there's also a more powerful type of ammo with superior penetration.
From the footage here,
You can see it's mounted on a metal belt, round after round connected.
even during firing, they're fed continuously.
Compared to the previous two types, these are also much larger. If I had to guess, they're definitely long-range rounds used in machine guns.